The drawing below is the scale drawing of a garden. What is the scale ratio of the garden? So we'll call this one as our original. This one is our real world. Think about this as x and y, so we'll have y over x for this corresponding side is 16 over 12, and that simplifies to 4 over 3. Answer choice C. Moving over here to the second problem, it says what is the ratio of the areas for the problem above? So we know the ratio of the areas is simply the scale ratio squared, or scale ratio times itself. So it tells us this would be 16 over 9. And finally, if we know the area of the first figure is 4 centimeters squared, which equation would be used to find the real area? So looking at this, we know that this is going to be A2, which is our real area, is equal to 16/9 using our area ratio times the original area, or our starting area, in this case our scaled area. And so that means the 4 is going to go in there, so we're going to get that A2, or A real, is equal to 16 over 9 times 4. That's answer choice C. So, C's all around. Alright, let's go ahead and move on and look at Alright, Kipsters will be able to identify and use area ratios and scale problems, or scale figures. Okay, so the first exercise here is really just making sure we understand the relationship between the scale ratio and the area ratio. Remember that we talked about this yesterday, where the scale ratio is just multiplied by itself to get the ratio area, or the area ratios. Ratio of the areas is k squared, so that's the scale ratio squared. So this would be, if the scale ratio is 5, then the area ratio is 5 times 5, which is 25. If the scale ratio is 7, that means that the area ratio is 7 times 7, which is 49. If the scale ratio is 1/8, go ahead and do that one. Should be 1/8 times 1/8, which is 1/64. The scale ratio is 2/3. Go ahead and do that one. Should get that area ratio would be 4/9. Now, this one's a little bit different. We're given the area ratio, and we're asked to find the scale ratio. So we've kind of got to go backwards. We've got to think, well, what times itself? What can I multiply times itself to give me 25? This is actually the concept of taking a square root, which we've not learned about specifically, but we can sort this out right now. What times itself would give me 25? Well, that's 5 times 5. So the scale ratio would be 5. We can see that this kind of goes backwards. So here we are with 36. What times itself would give me 36? That's 6 times 6. That tells me the scale ratio is 6, because 6 times 6 would be 36. Gets a little bit more complicated with the fraction, so I have to have the same thing top and the same thing on bottom. What times itself would give me 1? Well, that's 1 times 1. What times itself would give me 16? That's going to be 4. So we can see that it's 1/4 times 1/4. Okay, again, going backwards there. And finally, we see that the same thing here, what times itself would give me 9 on top, so it's going to be 3 times 3. And what times itself on the bottom is going to be 2 times 2. So the scale ratio must be 3/2. So again, if we're going backwards, we're trying to figure out what times itself would give us that value. We're going to use that concept here in a couple of these quick word problems. Here it tells us we have a scale drawing that has an area of 12 centimeters squared in the real world and an area of 300 meters squared. It says, what is the scale ratio of the drawing? So here we're just going to go back to our general equation for areas, area ratios. The area of a second figure is equal to k squared, okay, because k is the scale ratio, and k squared is the area ratio, times the original area. So our original area is our scale drawing. That's our input times 12, and this would be 300. So I'm going to divide both sides by 12. And that's going to give me that 25 is equal to k squared. So remember, this is an area problem, and we use the area equation. So right now what we have, k squared here is the ratio of the area. So what I need to figure out is I need to take that backwards. What times itself would give me 25? And again, we've already seen that example a couple times. So the scale ratio, so our area ratio is equal to 25. So our scale ratio is equal to 5. Alright, a scale drawing has an area of 3 centimeters in the real world and an area of 108 meters squared. On the scale drawing. So what is the scale ratio of the drawing? So again, we're looking for the scale ratio here. And when we see this, again, we have area of the real world is equal to area the k squared. We can just call that our area ratio times the original area, our scale area. So this is our real world here is 3 is equal to, nope, sorry, the drawing is 3, so let's go ahead and fix that. Our drawing here is 3. In the real world, it is 108 k squared. So I want to figure out what my area ratio is. I want to get that k squared around, divide by 3. It's going to give me that k squared is equal to 108 divided by 3. That'd be going 1 time 16, 36. So the area ratio equals 36. And if the area ratio is 36, we're thinking about the scale ratio, what times itself gives me 36, and that would be the scale ratio is 6. Alright, so it says a scale drawing has a side. Now this is where we've got to be careful. We're looking at a side here now instead of an area and the corresponding side. So this is going to give us directly our scale ratio. So we're going to have side 2 is equal to the scale ratio, just k, times whatever the original is in the drawing. So in the drawing, it's got a side of 3. So k times 3, and we get that the real world side would be 108. Divide by 3, divide by 3. So that tells me that k, or the scale ratio, is equal to 36. So again, this happens, we don't have that extra work to do. because we're given sides here. So we're using the side equation, which gives us the scale ratio directly. Right. We have a scale drawing uses 3 inches to represent 5 feet in the real world. Use this to answer all of the questions below. So here is our x. This is our input and our output is 5. So we have y over x is 5 over 3. So our scale ratio k is equal to 5 thirds, which means our area ratio is 5 thirds times 5 thirds, which would be 25 ninths. And from 5 thirds times 5 thirds, the area ratio is just the scale ratio times itself. So the equation for sides is that a side in a second drawing or in the real world is equal to the scale ratio, which is 5 thirds times whatever the side in the drawing is. So for our area equation, it's the same idea, except we're using our area ratio, 25 over 9 times the original. If the drawing has an area of 36 square inches, what is the area in the real world? So area of our drawing, that's our original area. So area 2 we don't know, that's what we're looking for in the real world. 25 ninths times 36. Plugging into this equation up here, the 36 in for the drawing area. And when I do that, I'm going to get that A2 is equal to 100. And we're looking for the real world, so the real world units are feet, so this is square feet, or feet squared. If in the real world it has an area of 100 square feet, what is the area in the drawing? So this one's a little bit different. We're given the area in the real world. So this is given area 2 is equal to 25 over 9, again using the area equation because we're talking about areas, times, we don't know the scale drawing area. So this one requires a little bit of solving here. We need to divide both sides by 25 over 9. Divided by 25 over 9. So we have 100 divided by 25 over 9, which is actually the same thing as 100 times 9 over 25. Doing a little cross canceling there, we're going to get that A0 is equal to 36. And our units, this is inches squared. If the drawing has a side of, hint, we're talking about sides here now, we're not talking about areas, so we're going to be using our area, or our side equation, which uses the scale factor 5 thirds. So S2 is equal to 5 thirds of S naught, or S of the original drawing. The drawing has a side of 30, so this is going into 35 thirds times 30. And so what we're going to see here is that S2 is equal to 50. This is the real world, so those are 50 feet. If there is a real world distance of 30 feet, so now we're looking at a distance, again, this is not an area, so we're talking about length of sides here. Side 2 is equal to 5 thirds side of the drawing. This is the real world distance is 30, so that's going to go in for my S2. 5 thirds times, we don't know what it is in the drawing, divide by 5 thirds. Divide by 5 thirds. So we get 30 divided by 5 thirds. which is the same thing as 30 times 3 over 5. And that's going to give us that S naught is equal to, divided by 6 times 3 is going to be 18. And this is in the drawing, so 18 inches. Okay, so basically what we're seeing here is the same kind of concept that we've seen before. We're going to use our ratios to write the equation. So if it's a area ratio, or if it's an area, we're going to use the area equation with the area ratio. If it's a side, we're going to use the side equation with the regular scale ratio. And really, that's all there is to it in this unit. Continuously doing the same thing that we've been doing. Create your equation using the ratio, and then go ahead and use the equation based on the information that you have. Alright, so let's go ahead and flip on over to our partner work. Make sure that you finish your partner work before you move on to go ahead and check the video. Okay, so looking at this, hopefully at this point you've gone ahead and got this solved, so you should just be checking. Looking at this, we have a scale drawing, uses 1 inch in the drawing, 1 inch in the drawing to 5 feet in the real world. So we have a y over x of 5 over 1, so our scale ratio is 5, thus meaning the area ratio is 5 times 5, which is 25. So our equation for our sides is side 2 is equal to 5 times side 0, or our drawing side. Area 2 is equal to 25 times area of the drawing. Alright, so if it says the drawing has an area, so I'm going to be using my area equation. Area 2 is equal to 25 area 0. The drawing has an area of 36 feet. Alright, so A2 is equal to 25 times 36. Doing some of that math, this is going to be equal to 900. Looking at our units for real world, should be square feet, feet squared, whichever way you want to write it. Alright, this one says the real world area. Again, we're looking at our area equation. Area 2 is equal to 25 times area 0. This is the real world area, so that's going to go over here on this side. Go ahead and solve the equation by dividing. We're going to get that A0 is equal to 4. This is 0. That's in the drawing, so this is some number of, let's see, what are we measuring up here? In inches. Alright, the drawing has a side. Okay, it jumps out at me. We're talking about sides here. Side 2 is equal to 5 times side on the drawing. Drawing has a side of 30, so this means that's 5 times 30. In the real world, good. So S2 is equal to 5 times 30, which is 150 feet. Not an area, just the length of the side. The real world distance is 30 feet, so the real world distance, so again, S2 is equal to 5S0. Real world distance is 30, so this is going in over here. 5 times S0 divided by 5 divided by 5. And that should give me that S0 is equal to 6. And we're talking about the drawing, so we're talking about inches. Alright, go ahead and make sure that you've jumped through all these. It says a scale drawing has an area of 20 centimeters squared in the real world and an area of 720 meters in the real world. So the scale drawing, so this is going to be using an area equation. We don't know anything about it. K squared, remember that's the scale ratio squared in the area equation. Drawing is 20, so this is going to be plugged in for 20. This one is 720. So again, we're using the area formula. So when we do this division, when we go ahead and divide by 20, 36 is going to be equal to k squared. That's not the scale ratio, that's the area ratio. So in order to find out what the area or the scale ratio is, I need to figure out what times itself gives me 36. So that tells me that k is equal to 6. So we have a 6 to 1. This is 6 times larger. K is equal to 6. A scale drawing has an area of 4 centimeters squared in the real world and has an area of 100 meters squared. What is the scale ratio? So again, we're going to be using our area formula. In our area formula, we're not given the scale ratio. We'll get the area ratio, which is just the scale ratio squared. The drawing is 4. In the real world is 100. Divide by 4, divide by 4. It's going to give me 25 is equal to k squared. So again, this is the area formula. So right now this is giving me the area ratio. And if it's giving me the area ratio, then I just need to figure out what times itself. K is equal to 5. 5 times 5 would give me the 25. Alright, this one has a scale drawing, has a side and a side. So we're using our side formula. Side 2 is equal to k, just regular old k. This is going to give me the scale ratio directly. Side 1. So this is the scale drawing is 20. And the corresponding side in the real world is 100. Divide by 20, divide by 20 tells me that k, the scale ratio, is equal to 5. This is a 5 to 1 scale. Scale has an area of 12 centimeters in the drawing. So again, we're looking at area. What is the scale ratio of the drawing? So area 2 is equal to k squared times area 0. The drawing is 12. 48 over here. Go ahead and dividing. We're going to get 4 is equal to k squared. And so that means that the k is whatever times itself, so that gives me 4, which is 2. K is equal to 2. Scale ratio is 2. A scale drawing has a side again, so I'm looking at sides here. Don't know my ratio. That's what we're trying to figure out. Except it's not going to be k squared. This is just the side equation times the original side. So our drawing is 30. K times 30. And corresponding side in the real world is 10 meters. Divided by 30. Divided by 30. We're going to get k is equal to 10 over 30, which simplifies to 1 over 3. Alright, that should be it. Let's go ahead and move on to our independent work.